it's too wide, you have a horizontal scroll bar, so it sort of things. Yeah. Okay.
See, this is one of my practice class maps. It's really exciting and colorful.
When the basic idea is to make access different.
Here at the University of California, Berkeley, the Bay Area Research Wireless Access Network, or BARWAN, seeks to develop and demonstrate advanced wireless technologies for providing continuous internet connectivity across the local, campus, metropolitan, and wide areas. BARWAN integrates wireless local area networks, campus area packet radio networks, cellular digital packet data, direct broadcast satellite, and wireless cable modems into a unified set of overlay networks. Our overarching goal is to make good on the statement that people and their machines should be able to access information and communicate with each other easily and securely in voice, data, image, video, or multimedia, anytime, anywhere, in a timely, cost-effective way. The increasing reliance on the web worldwide has made continuous connectivity to the Internet mission critical. BARWAN's research innovations come in two areas: wireless networking and mobile application support. In wireless networking, we have developed a pioneering architecture that supports seamless mobility across heterogeneous wireless subnetworks. We call these subnetworks wireless overlay networks because they are stacked one on top of the other, with the lower overlays yielding high bandwidth over a small area and the higher overlays yielding lower bandwidths over a larger area. Let's see how wireless overlay networks achieve continuous connectivity as a user moves through these different networks. Here Todd is using his computer connected by a room-sized infrared or IR network.
Okay, Steve, I'll check it out. Why don't you walk me through it?
As he walks into the corridor, he leaves the range of the IR network, and his laptop automatically switches its connection to the building's radio-based wireless local area network, or wireless LAN, without any intervention. We call this handoff between wireless subnets a vertical handoff, as opposed to horizontal handoffs within one wireless subnet. The only indication that he has left one network and entered another is the connectivity diagram on his computer screen. As Todd leaves the building, he leaves the coverage of the high-bandwidth wireless LAN and switches over to a much slower speed Metrocom packet radio network that covers the Berkeley campus. Notice how the quality of the downloaded images changes when the computer switches to a slow-speed wide-area connection. This seamless adjustment to reduced bandwidth and increased latency in the move to the campus packet radio network is made possible by our second major innovation, client proxy server processing. We've introduced a powerful mediator between the server and client that instantaneously optimizes the format of data for the available bandwidth. This mediator, called a proxy, harnesses scalable processing resources in the form of networks of workstations to support application and data-specific adaptation to large variations in network and latencies. Small portable computing and communications devices are becoming more ubiquitous, but they have limited computational and storage capabilities and cannot display full-color images. This is where the proxy comes in. Proxies adapt popular web-based and digital video representations for efficient display on wireless devices. It stands between the server and client, intercepting information destined for the client. Sending the client a full-color image it cannot render because of its display limitations wastes network bandwidth. So the proxy distills the image into a more compressed, low-resolution form, delivering it to the client in substantially less time than the original image would have taken. Here is a typical web page after it has been processed by the proxy. Note how the images appear to have lower resolution. A user can personalize the proxy to trade quality against processing and transfer time, and the full-scale original is only a click away. The comprehensive system architecture we've developed starts with existing wireless subnetworks. A link scheduling layer optimizes the delivery of real-time data to wireless clients. A special snooping agent improves transport layer performance by locally repairing lossy wireless links. The underlying subnetworks are integrated by adding overlays to the Internet's mobile IP routing protocols. On top of this is a special modified transport layer that handles asymmetric and heterogeneous links. Proxy services are implemented on top of the architecture's routing and transport layers, and mobile applications are constructed on top of these. Cross-cutting elements for network connection monitoring, network application interfaces, and explicit loss notification implement the concept of a session, the coordinated management of the communications between a client and a server.
Okay, Todd, I did a little bit of research. You need to get a 25-pin, not a 9-pin cable, if you can.
Sounds great.
The BARWAN project has shown conclusively that wireless access can be extended virtually everywhere through wireless overlay networks. Even small and simple devices can have full access to all of the servers and services on the Internet with the help of proxy services. Access truly is the killer app.